Today's lesson objectives are 4.2E and 4.2H. 4.2E states represent decimals including tenths and hundredths using concrete and visual models and money. 4.2H reads determine the corresponding decimal to the tenths or hundredths place of specified points on a number line. To begin with, we need to understand how to read a number line. So here are a few examples of how we could place two decimal values on two different given number lines. In the first example, they're asking us to place the decimal 1.2 on the number line below. If you look at the number line closely, you can see that the numbers range from 0 to 2, meaning that halfway in between, you would have the number 1. So if I was answering this question, I would begin by writing in the value of 1 here. So I know that that's what that long mark represents. Then I would look at how many marks or how many sections we have in between each of our whole numbers. Notice we have 1, 2, 3, 4, and 5. Okay? So if each whole is broken into 5 equal sections, it means you're dividing 1 by 5. And if we divide 1 by 5, that gives us a value of 0.2, meaning that each of these markings is worth 0.2. So you have 0.2, 0.4, 0.6, 0.8, and then 1.0, or just 1. Now, if we continued this pattern, we would know that beyond the 1, going to the next number 2, we would also use count by 0.2s. So we'd have 1.2, 1.4, 1.5, and 1.6. Okay. Once we've labeled our number line, it becomes much simpler to see where the point 1.2 would fall. It would fall here at this location. Now, on the second example, we're looking at placing the decimal value 1.35, or 1 in 35 hundredths, on the number line provided. Now this one's already detailed out a little bit more for you. You have the 0, the 1, and the 2, but notice you have quite a few more markings in between each of the values. So to figure out what each of the markings is worth, again, we could count how many sections there are. Okay, so this would be 1 section, 2, 3, 4, 5, 6, 7, 9, 10. Okay. Notice that's midway between 0 and 1, so it's 10 sections to there. So you would expect it to be another 10 sections to reach the 1. So that's a total of 20 sections. So we could divide 1 by 20 to see what we get. If we do that, we find that each one is worth 0.05. So each of these tiny marks counts up by 0.05. Okay, so I've labeled each of the markings 1 through 20 to see if there's 20 spaces from the 0 to 1. I've shown over here that if you divide 1 by 20, you would have to add 2 decimal places in order to divide it, so 1.00. And so 20 can't go into 1, so that's 0 times. 20 can't go into 10, so that's 0 times. But 20 can go to 100 5 times. So it has a value of 0.05. So each of these tiny markings will be worth 0.05. So if you notice, that would make the second marking. If you add 0.05 to 0.05, you get 0.10. Then if you add 0.05 to 0.10, you get 0.15. So you can see there's a pattern here. Each time it's counting up by an additional 5 hundredths. So you go 0.20, 0.25, 0.30, 0.35, so on and so on. Okay? Now, the values are the same even after the whole number 1. You just add the whole number to it. So this first mark here would be 1.05, 1.10, 1.15, 1.20, 1.25, 1.30, 1.35. And that's the mark that we're looking for. We want the one that represents 1.35. Okay? So when given a number line and trying to place the decimal where it goes on the number line, the steps are to find the number of increments that the lines are breaking up the whole numbers by. So in this case, 20 spaces. Okay? Divide the whole number 1 by that number of spaces. You'll probably need to add the decimal and the zeros in order to be able to do so. So you can find out how much each space is worth, or each mark is worth. Once you know what each mark is worth, you can simply add that value each time to get to the next mark, and so on and so on, until you reach the whole number 1. Okay? If the decimal you're trying to place is beyond the 1, just realize that the markings are still worth the same amount. It's just now 1 point that much. So in this case, 1.05, 1.10, 1.15. Okay? Another way to look at decimals is on a decimal grid. Decimal grids, basically, you have to determine what you want to be your whole. If you're dealing with a decimal that's in tenths, like in this example here, 1.2, the 2's in the tenths place, then it would make sense to break, if the whole square represents 1, break it into 10 equal sized pieces to show tenths. And so if I want to show 1.2, I would shade in 1 complete square for 1, and then 2 of the next square to represent 2 out of 10, or 2 tenths. You can do the same thing with hundredths. The only difference is this time, for your whole, you need a grid that shows 100 spaces instead of 10, like we had before. So again, if I want 1.35, I'm going to shade in 1 whole grid, and then I'm only going to shade in 35 of the squares on the next grid to represent 0.35. So it's 35 out of 100. Okay? So this is how you do it using decimal grids. Another way to represent decimals is using what we call decimal disk. Decimal disks are circular disks that can be broken into whatever number of segments you need. So again, if I'm wanting to show a number that has tenths, in this case 2 tenths, then I need to break the circle into 10 equal sized pieces. So 1.2 would require 1 full shaded circle and 2 of the next circle to represent 2 out of 10. Okay, kind of like the decimal grid that we just looked at. Now this one, you're trying to do hundredths. If you were to actually cut your circle into 100 equal sized pie pieces, that would be each of these tiny little markings you see along the outer edge. That would be a lot of really tiny pie pieces, and so that can make it visually hard to see or count unless you had a really large circle to do this with. So here we're just indicating each of the pie pieces by one of these little markings. Okay, so there's a total of 100 markings if you go all the way around the circle. So if I want 1.35, I'd still shade in 1 whole circle for the 1, and then I would count out 35 marks. Well, every long mark is 10, so here's just going to be the first 10. 10 more makes 20, 10 more makes 30, and then 5 more marks to get to 35. Okay, so this would be showing 35 markings out of 100 possible markings for 35 hundredths. We can also do it using base 10 blocks. With base 10 blocks, you simply use, depending on what you're trying to represent as your whole, if we use a flat to represent our whole, then we would, for 1.2, we need 1 full flat, and then a flat could be broken into 10 longs, right? And so if I want to model 2 tenths, then I would need 2 of those longs to represent 2 out of the possible 10 that make up the whole. So 1 flat would be my whole, and 2 longs could be my 2 tenths. Same thing with hundredths place. Again, I'm letting here the flat represents a whole. So if I let each little block, each tiny unit block, represents a hundredth, okay, then I can do 1 whole with the flat. I got 3 tenths, so 3 longs, and then I need 5 hundredths, so I use 5 of the little unit cubes, because it takes 100 of those to make up a whole, right? So the place value will determine which piece you need. A flat would be a whole, a long would be a tenth, and then the little units would be hundredths. Finally, we can also use money to represent decimals. Here we have the decimal 1.2 again. In money terms, that's read as $1.20. So we would use a dollar bill and 2 dimes as our 20 cents. Now I know there's other combinations of coins we could use and still be correct. You could use 4 nickels or 20 pennies, and that's fine as long as the value adds up to be $1.20. The other example, 1.35 in money terms would be read as $1.35. So again, we use a dollar bill for the dollar to represent our whole, and we could use a quarter and dime to represent our 35 cents. Okay? Alright, now in this next section we're going to look at locating the name of a point on a number line. So here would be an example. They would give you a number line like the one you see here at the top. It would already be broken up into increments for you. The increments may or may not be labeled. They're going to place a point somewhere on that number line, and you're to identify the value of that point. So just like before, if it's an unlabeled number line, we need to figure out what each increment's worth. So to do so, we'd use the same process. We would count the number of spaces between 0 to 1. Sorry for the sloppy writing here. So you can see there's 10 spacings. Then we divide 1 by the number of spacings. So here we're going to divide 10 into the number 1. Now again, 10 can't go into 1, so we add a decimal, we put a 0 here. Now 10 couldn't go into 1, but 10 sure can go into 10. It can go in there one time. And so we can see that each space is worth 1/10. So that's how they knew to label each space worth a tenth. So you get 1/10, 2/10, 3/10, so on, until you get to 10/10, which is a whole. Then you can clearly see that point A falls at 0.6. And what you labeled what each space is worth. Okay, here's another one. This time, notice we didn't start at 0, we're not going to 1, but we are still representing a whole, because we are showing going from number 2 to number 3. That's one whole, right? That we've gone from 2 to 3. So again, the spacings can be found out the same way. If you're just showing one whole on your number line, you can still count the number of spaces in order to figure out what to make each space worth. Now it just so happens with the example I provided, there's going to be 10 spaces on this one as well. So when you divide, now don't get tricked here, we're not dividing 10 into 3, that's not what we're doing here, because we're still talking about just one whole, right? Because we only went from the number 2 to the number 3. So I'm still going to divide 10 into one whole, just like I did before. Okay, and we'll figure out, again, just like before, that's equal to 0.1. So each marking is worth a tenth. So if we're already at 2, this is going to be 2 and 1/10, 2 and 2/10, so on and so on, until you get to the 3. Okay, so that's done for you down here. So you can see that the A falls at 2.4. Alright, so even when your number line doesn't start at 0, if the number line they're giving you still just represents one whole, in this case just going from 2 to 3, so that's one whole, the process is still the same for finding out what each marking is worth. Alright, our last examples here, these are related to hundredths. And it's the same kind of question. They give you a number line, 0 to 1. Here we have a point A on the number line. They're asking what is the value of that. So again, you could count the number of spaces. I would probably look at the longer lines. See the longer, darker lines? You'll notice that there's actually 10 of those from 0 to 1. So basically from here to here, if you count that as one space, then you'd have 2 spaces, 3 spaces. Okay, so we're talking about here to here, here to here. Whoops. There's a space. And so you can see there's 10 spaces if you do that, using just the long lines. So that tells me that, again, just like before, since I'm dealing with one whole divided by 10, each of those long lines is worth a tenth. So I label those first. Now, there's these a little bit longer, but smaller lines halfway in between each of those long lines. And so that would be halfway between a tenth. Well, half of 10 is 5, right? So if this is 10 hundredths, then half of that would be 5 hundredths. So each marking in between is worth 5 hundredths. Alright, and so then you can label those. So that tells you each little marking is worth a hundredth. So you got 0.56, 0.57. So now you know where to place your 0.57. Do the same thing with this one. This point A, the only difference is our starting amount is 1.6. So if each little mark is worth a hundredth, we can say there's 10 hundredths, 20 hundredths, 25 hundredths, 26, 27. Okay, so there's 27 hundredths past 1.6. So we add that to 1.6, and we get 1.87. That concludes our lesson. Thank you.